Hello guys, welcome to another video, and we are going to be talking about DTLS versus SSL and also TLS. Let's go ahead and get started with this. So before we start, let's go ahead and do a little bit talk about the history about SSL. So it was developed by Netscape in 1994. The SSL protocol quickly became dominant for the use in applications and servers when transferring secure data across the internet. You know, whenever you're buying stuff, whenever you're logging in, you want to make sure that you are using a secure connection. Also, whenever you are swiping your credit card online and doing all that, you want to be secure. And you know, back then, during the consumer infancy of the internet, the World Wide Web Consortium decided that a secure way to transfer web traffic across the internet was needed to encourage e-commerce providers onto the internet. You guys remember back in the days when people were saying that you were going to be able to buy stuff online, and they were like, no, you're crazy. How are you going to enter your credit card on a website and you're just going to pay for it like that? Like, you're crazy. That's never going to happen. And look now, you're able to do that and a lot more. And what is SSL, guys? Well, SSL provides message authentication, authentication, confidentiality with encryption, and integrity with hashing algorithms through the combination of the underlying cryptographic protocols. And how are SSL and TLS similar? Well, SSL and TLS are cryptographic protocols that authenticate data transfer between servers, systems, applications, and users. For example, a cryptographic protocol encrypts the data that is exchanged between a web server and a user. And they both do that, and they are very, very similar. Some of the differences between SSL and TLS. The Cipher suite. So SSL protocol offers support for Tesla Cipher suite. TLS does not offer this support. TLS offers a better standardization process that makes defining a new Cipher suite easier, like RC4, Triple Test, AES, and IDEA. But you don't want to do any. You want to use AES 256 list. And also, another difference between SSL and TLS is that those alert messages. SSL has the no certificate alert message. TLS protocol removes the alert message and replaces it with several other alert messages. And there's here more. The record protocol. So SSL uses message authentication code, or MAC, after encrypting each message, while TLS, on the other hand, uses HMAC, a hash-based message authentication code after each message encryption. Right? So what it does is it encrypts it and then it just hashes it. That's what HMAC does. And also there's a different handshake process. In SSL, the hash calculation also compromises the master secret and pad, while in TLS, the hashes are calculated over a handshake message. So it is the same protocol, SSL and TLS, but TLS just makes it, takes it to another step. It's just a little bit better than SSL. And they also do the message authentication different. SSL message authentication adjoins the key details and application data in ad hoc, while TLS version relies on HMAC, hash-based message authentication code, just like I said before. And what about DTLS? What in the world is DTLS? Who came out with DTLS? I feel like there's a lot of people out there just sitting in the basement, like I am right now, just thinking about what to do. Like, let's just create a new protocol. Let me just, draw on the board, and here is a new protocol. Here you are, DTLS. I think that's how DTLS came up. And if you guys recall that SSL and TLS, they use TCP, right? And because of the need for support for message reordering, retransmission, and reliable delivery purposes. That's why they use TCP, right? Because if you lose the packet, you want to get it back. and that's why they use TCP, because TCP is able to reorder and retransmit, and it's more reliable than UDP, and that's why SSL and TLS uses that. But somebody came out with DTLS, and that is for many delay sensitive protocols like voice and video. A lot of that is now really encrypted, and video and voice does not use TCP, it uses UDP. That's why DTLS came up. It is basically a SSL and TLS, but using UDP instead of TCP, right? And some engineers, needed to send delay-sensitive applications through an SSL and TLS tunnel, and because SSL and TLS, like I said, it says TCP, it uses TCP. The voice and video was not really going to work, so they needed to just take SSL and TLS and just add UDP instead of TCP, and that's why they came out with DTLS. And DTLS is based on the original implementation of TLS, like I said, but instead operates using the UDP transport protocol for faster packet delivery, so you can have voice and video. Additional parameters, fields, and functions allow it to provide reliable message delivery, message reordering, fragmentation, and entry replay natively. To provide the functions of message reordering and reliable delivery, the DTLS protocol has added 2 new fields to the TLS record layer format: sequence number and epoch. Also, the sequence number increments for each packet sent between the client and the server. DTLS also uses windowing, which TCP uses, the windowing system, for entry replay purposes, providing the protocol to be able to distinguish between packets that are yet to be received and the ones that it should receive. And that is it for this video on DTLS, SSL, and TLS. So they're basically TLS, but the DTLS, it is just TLS but uses UDP. And SSL and TLS, TLS, it just has better encryption and better everything than SSL. That's what it is. And let's just start labbing, guys. Let's just do a lab. And for this lab, let me see if I configure everything. I think I did it on the video before, but I want to make sure that nothing was saved here. Let's go ahead and do show IP interface brief. I don't think anything was saved. Nope, nothing was saved. So let's go ahead and configure everything, guys. The host name, I want to name this R3. Interface gigabit 0/1. Let's give an IP address of 20.1.1.1. Not shut down. Then you want to go to gigabit 00, which is the one going to 192.168.1.3 or the 3.1. Still not shut down. Then we want to do exit IP route. Let's just add a default route, and I want to send everything to 20.1.1.2. So we are switching this 20.1.1.1 and 20.1.1.2. That's just how I did it. Okay, so we are done, and let's save it. Good. Now let's go ahead and configure the ASA. The ASA needs to have a lot more of configuration. Why is it rebooting right now? Well, while that is rebooting, let's go ahead and configure the IP address of the ASDM and of the website as well. And let's go ahead and bring up over here while this is rebooting. Let's go to ifconfig interface 0. And what is the interface? IP address 192.168.1.1. Net mask 255.255.255.0. Well, actually, now that it's going to be that too. ifconfig. Then we do a route add default gateway 192.168.1.1. Let's go ahead and configure the ASDM now. And the ASDM just keeps rebooting for some reason. What we could do is, let's go ahead and just remove this bad boy. Let's go ahead and add it again. Yep, I had Palo Alto. I'm working on that, guys, just for you guys, because I love you guys. Let's go ahead and also configure it. Let's see if it lets me use Telnet. There we go. Hopefully it lets me use Telnet. Okay, let's go ahead and configure the IP address for the ASDM, which is going to be, let's go ahead and go to the terminal, ifconfig, interface 0, 1.1.1.2, net mask, 255.255.255.0, route, add default gateway 1.1.1.1. Cool beans. Now let's go ahead and see if the ASA firewall is up and running. It's still not running. Let's go ahead and just plug everything in. This one is going to go to the management interface. This one is going to go to 0.0. This one is going to go to 0.1. Also at 0.1. Let's go ahead and verify it. See if ASDM is still not running. It is still reloading. So let's go ahead and go to the Windows device and configure this IP address while the ASA is coming up. Let's go ahead and go network adapters. Let's go ahead and remove 192.168.3.2, 192.168.3.1. Close it. Say yes. We should be able to do a ping 192.168.3.1. Yep, we have a connection. So my ASDM, or my ASA, not my ASDM, my ASA doesn't want to work today. Let's go ahead and try this over here. See if this one works. This is the other one. Management interface right here. Let me verify. This one's already up and running, so we are going to be using this one instead of this one. So let's go ahead and stop it. Delete it. Adios, amigo. Go ahead and add this ASA right here. Management 00 01 01. Cool. So let's go ahead and don't start rebooting. Let's go ahead and pause. Am I going to have to pause it? Let's see. I don't want to make you guys wait or anything, so I'm just going to pause it. Okay, so the ASA is up and running now, so let's go ahead and configure that bad boy. Config T, interface gigabit 0/1, which is this one. This is the management. Making sure you don't get confused. This is this one. Gigabit 0/1, IP address 20.1.1.2. Name if this one is going to be the outside. Now shutdown. Now we go to gigabit 0/0. IP address 192.168.1.1. Name if inside, now shut down. Let's see if we're able to ping 192.168.1.2. We are, so we were able to ping this website right here. Good. Now let's go ahead and do interface management 0/0. IP address 1.1.1.1. Name if management. No shutdown. Ping 1.1.1.2. Good. Ping 20.1.1.1. See if we're able to ping the router. We are. That's great. So now let's go ahead and do enable HTTP. Then HTTP. We are going to let any IP address connect to it, which is not really good. Then we're going to do management. Then we're going to do a route to the outside, a default route. Send it to 20.1.1.1, which is the router. So now we should be able to ping 192.168.3.2, which is the Windows device. So we're able to ping that Windows device. Good. Let's go ahead and save my configuration. Now let's go ahead and access the ASA via the ASDM, which is the GUI interface of this firewall. Let's go ahead and configure let's go ahead and launch it. 1.1.1.1. Say yes. We don't have a username or password, so you can just click OK. So you can log into it. And here we go. We are inside the ASA. So what we're going to be doing, we first are going to be configuring not a site-to-site, a clientless SSL VPN. SSL, okay, so we're going to be using SSL. Well, actually, let's not do the wizard. That's just for people that don't know how to configure. So let's go ahead and go to configuration. Let me go and be fancy and do a remote access VPN. We are going to do a clientless VPN. We are going to create a connection profile. Let's go ahead and apply that. Let's go ahead and add a connection profile. This one's going to be called SSL connection. And we are going to be using the local. So that's good. We are going to use the default DNS. We are going to create our own policy. SSL policy. Oops, press enter by accident. Edit. We are going to say welcome. Whenever you're logging, welcome to SSL clientless VPN connection. Okay. Say yes. Enable it. Apply it. Save it. Let's go ahead and create a new user. Local user. Oscar. Password Cisco. That's the password that I use for everything, guys. So if you want to log into my Twitter account, the password is Cisco. Apply it. Save it. Let's go ahead and go to group policies and let's attach that username to that policy so we are able to remote in. Good. After that is done, let's go ahead and go to the portal. Let's create a new one. Manage. And we want to add a URL. Bookmarks. This one's going to go website. And the website that we want to go to is 192.168.1.2, which is this website right here. Apply it, save it. So now we just have configured a clientless SSL VPN connection. In a clientless SSL VPN connection, you're able to access these ASA via a web browser, so you don't need to install any software, and that's going to take you to different places inside this network, like the website, for example, just like we added that bookmark to go to that website. So let's go ahead and bring up that Windows device. And inside this Windows device, we're going to open whatever you want. Let's go ahead and open Mozilla Firefox. We're going to go to HTTPS //20.1.1.2, saying that it's not secure because we have a self-signed certificate. So the self-signed certificate is not a trusted certificate, but we are just going to add an exception, confirm it, and here we go. Now we're going to log in with my username and password. There we go. Don't save. And you can see the banner that we added. Welcome to SSL Clientless VPN connection. Continue. And here we go. Here's the bookmark that we created. Go to that website, and here it is. So we are inside that website using just the web browser, not using any software. But if you want to use a software, what you could do, also let me do a CMD IP config so you can see my current IP address is this one. But whenever we connect, we're going to get an IP address that we're going to configure in this ASA. So let's go ahead and just do a wizard so we can do it a little bit faster. I don't want to make this video too long. We are going to do an AnyConnect VPN wizard. Next, name. This one's going to be SSL AnyConnect to the outside. We are just going to enable SSL. We don't need an image, or you can just add whatever you want. I already have an image. You can just add that. That's fine. Next, authentication. Why don't we go ahead and create another one? Let's just call it VPN. Cisco. We are going to add a pool or IP addresses. This one's going to be AnyConnect pool. We are going to start at 192.168.10.1.10, and it's going to go all the way to 192.168.1.13. So whenever I connect, I'm going to get an IP address in these ranges from that 1.10 to that 1.13. But we are going to get the first one whenever I connect. Click OK. Next, we're not going to do that. Say no. NAT traverse is good. Finish that bad boy up. I got an error. The error saying that just the AnyConnect image. That's fine. I didn't use a proper image, so that's fine. I don't need to add an image because I already have Cisco AnyConnect installed on my Windows device. So why is it not letting me click on finish? Don't start GNS3, come on. No, I want to finish the damn thing. Let's go ahead and go back. Next. Oh, it's not letting me do it. I think this thing froze, guys. Now, next, finish. And it's not letting me finish. Let's go ahead and cancel. Click yes. Let's see if it was configured. It looks like it was configured. I can see the group policy. Let's see if we see the connection profile. It is there too. Let's go ahead and enable it to the outside. Group policy. Group policy is there. We don't have a user to it. Let's go ahead and add the VPN user. Good. Let's go ahead and go and see. Let's go ahead and go over here. Make this smaller. Local users are there. Advanced. So everything is there. It looks like everything is there. So I'm liking it. Let's go ahead and see if we are able to connect to it. Let's go ahead and go into my Windows device. AnyConnect. We are going to use 20.1.1.2. Not IPsec. Quit. AnyConnect. Open it again. 20.1.1.2. Connect. Here we go. It is contacting. There we go. Continue anyway. We are going to log in with VPN. Password Cisco.